To the video lecture of operating system. So in this lecture, we will cover the topic mainly Bango's algorithm. In Bango's algorithm, there are two algorithms, safety algorithm and resource request algorithm. And we will cover an example for Bango's algorithm. So Bango's algorithm. It is one of the deadlock avoidance algorithm. It is used in multiple instance resource allocation. So why it is known as Bango's algorithm? Majorly used in banking system. It helps to identify whether a loan should be given or not. So, for the implementation of Bango's algorithm, we mainly need four data structures. The first one is available. It is indicating the number of available resources of each type. And the second one is maximum. It defines the maximum demand of each process in the system. It is a 2D array. And the third one is allocation. It defines the number of resources of each type currently allocated to each process. And the last one is need. Remaining resource of need of each process. And there's an equation to find the need value maximum minus allocation. In Bango's algorithm, we have safety algorithm as well as resource request algorithm. So first we will see safety algorithm. So let's see an example problem. Here we have allocation maximum available. So let's assume totally we have five processes P0, P1, P2, P3 and P4 and assume three resource type that is A, B, C. Here resource type means it may be any resource. It may be a printer, scanner or any hardware device. So we have A equal to 10, that is 10 instance of resource type A, and B equal to 5, 5 instance of resource type B, and C equal to 7, 7 instance of resource type C. So the 10, 5, 7 are the total number of available resources in a system. So after discussing the algorithm, we will solve the problem with algorithm. Here the first step is work is equal to available. So it contain available number of resources of each type. That is work is available number of resources of each type. So next is finish of I equal to false. For I equal to 0, 1, 2 up to n minus 1. So initial value of I is equal to 0. Next I value become 1, then I value become 2 likewise. So we have to take finish of 0, process 0 equal to false. Next finish of I process P1 equal to false likewise. Finish of P4 equal to false. Here false indicating that the corresponding process is not executed till now. So the next step is find an index I such that both. Here we have two conditions. First condition is finish of I equal to false, and the second condition is need is less than or equal to work. So if the need is less than or equal to work, then only OS can allocate resources to the process. So the next step is work is equal to work plus allocation. So let us assume that P naught need is less than or equal to work. So P naught get completed its execution. So whenever P naught completes execution, then we can remove the allocated resources from P naught and add them to the available resources. So the next step is finish of I equal to true. It is specified that um, uh, so if finish of I equal to true, then it specifies that the process is executed. So if the process is executed, then go to step 2. So likewise, we have to check for the remaining process also, that is P1, P2, P3 and P4. So the last step is finish of I is equal to true for all I, then the system is in safe state. So Now let's solve the problem with the help of this algorithm. So this is the problem example. So the example is to illustrate the use of Banger's algorithm, consider a system with 5 processes P0 through P4 and 3 resource type A, B and C. Resource type A has 10 instances, resource type B has 5 instances and resource type C has 7 instances. Suppose that at time T0 the following snapshot of the system has been taken. So using this is the problem, process allocation management. These are all the given so this all are given in this question. So using this algorithm, we will find the system is in safe or not. So there are 5 processes naming from P0, P1, P2, P3 and P4 and there are 3 instances A, B, C. In the instance A is having 10 instance, B is having 5 instance, and C is having 7 instance. So the out of 10, the system is allocated 2 instance for P1, 3 instance for P2, and 2 instance for P3. So the total allocated is 2 plus 3 plus 2, that is 7. So 7 minus 10 minus 7 is 3. Likewise, we can write the available resources as 3, 3, 2. In this allocation, it is specified that the resource in this allocation, it is specified the resource currently allocated to each process and maximum specifies the maximum demand of each process and the available is the available resources in the system. So first we need to determine the need matrix. So need matrix can be calculated with the formula need is equal to need minus allocate, maximum minus allocation. So need for P naught is maximum minus allocation, that is 7 minus 0 is 7. Then 5 minus 1 is 4. 3 minus 0 is 3. Likewise, we can calculate the other need matrix, other process need matrix, need value. 3 minus 2 is 1. 2 minus 0 is 2. And 2 minus 0 is 2. Likewise, we can calculate 3, 0, 0, 0, 1, 1, 4, 3, 1. So after finding the need value for the safety algorithm, the formula is need is less than or equal to work. So work is the available number of resources in the system. So consider P naught. The need values is 7, 4, 3 and the allocate available resources is 332. So we need to check that 743 less than or equal to 332. That is 7 is less than or equal to 3, 4 is less than or equal to 3 and 3 is less than or equal to 2. So 7 is not less than or equal to 3 and 4 is not less than or equal to 3 and 3 is not less than or equal to 2. So we cannot allocate. So next, P0 must wait. So next we need to find the P1, process P1. So the new work value, so the need value is 112 is less than or equal to 332. Yes, it is less than or equal to 332. So the new work value. So the work value equation, to find the work value equation, work is equal to work plus allocation. So work 332 plus allocation 200, that is equal to new work value is 532. So we change the work value here 532, and state sequences. First we are allocating the process P1. So next we will find the process P2. Need is less than or equal to work, that is 600 is less than or equal to 532. No, 6 is not less than or equal to 5, 0 is not less than or equal to 3, and 0 is not less than or equal to 2. So P2 must be weight. Then we can find the P3, 0, 1, 1 less than or equal to 5, 3, 2. Yes, 0 is less than or equal to 5, 1 is less than or equal to 3, and 2 is less than or equal to 2. So new work value will be work is equal to work plus allocation. So the work value is 532 plus the allocated value is 211. So 5 plus 2, 7, 3 plus 1, 4, and 2 plus 1, 3. The new work value will be 744. And the save state sequence, first we allocate the process P1, then the next we allocate the process P3. This is the save sequence. So next we will calculate the process P4. 431 is less than or equal to 743. That is need is less than or equal to available. Yes, 4 is less than 7, 3 is less than 4, and 1 is less than 3. So new work value will be work is equal to work plus allocation, that is work is 743, the allocated value is 022. So 7 plus 0 is 7, 4 plus 0 is 4, and 3 plus 2 is 5. So the new work value will be 745. And the state sequence is first we allocated the P1, and the second we allocated the P3, and the third we allocated the P4. So next we will find the P naught value. So we completed one cycle. So we go for checking the next process which is not allocated, that is P naught is not allocated. So again we will check for process P naught. So need value minus available. So 743 is less than or equal to 745. Yes, 7 is less than or equal to 7, 4 is less than or equal to 4, and 3 is less than or equal to 5. So the new work value will be 745. Work is equal to work plus allocation. So 745 plus 010, that is 7 plus 0 is 7, 4 plus 1 is 5, and 5 plus 0 is 5. So the new state sequence is P1, P3, and P4 and P naught, and the new available that is new work value will be 755. So P2 is not allocated. So next we calculate for P2. So need is 600 for P2. Need is 600, and available or work value is 755. So 6 is less than 7, 0 is less than 5, and 0 is less than 5. Yes, it is true. So the new work value will be work is equal to work plus allocation. So 7 plus 3 is 10, and 5 plus 0 is 5, and 5 plus 2 is 7. So the new work value will be 10, 5, 7. That is this is the same state sequence. P1, P3, P4, P0, P2. So when the system allocates a system in this order, it will be in a safe state. So this is an example for safety algorithm. So next we will see resource request algorithm. Here the first step is If request is less than or equal to need, go to step 2. If the request is less than or equal to, then only OS can satisfy the request. The second step is request is less than or equal to available. If this condition is true, then go to step 3. In step 3, we have to add a request to the allocation. That is, so allocation is equal to allocation plus request. So automatically what happen is whenever we add request to the allocation, then available number of resources become decreases. So as well as need also decreases. So available equation is available equal to available minus request, and the need value equal to need minus request. So we will take in the same problem what we discussed in the safety algorithm. In this, we have 5 processes: P0, P1, P2, P3, and P4, and 3 resource type A, B, C. So initially, 10 instance available in A, 5 instance available in B, and 7 instance available in C. So now a process P1 is requesting 4102 to the system. So we have to solve by using resource request algorithm. Um, so the first condition is request is less than or equal to need. So request 102. This is the request 102 is less than or equal to need. P1 need is 122. So yes, 1 is less than 1 is equal to 2, 0 is less than 2, and 2 is equal to 2. Yes. So the next condition is request is less than or equal to available. So the 102, the request value is 102 and available is 332. So yes, that is also true. So the next we will go for allocation is equal to allocation plus request. So allocated. The allocated value is P1 allocation is 200 plus request is 102. So 2 plus 1 3, 0 plus 0 0, 0 plus 2 2. The new allocation value is 302. And we will find the available value. So available equal to available minus request. So available 3 3 sorry 3 332 minus 102. Request is 102. So that is 3 minus 1 2, 3 minus 0 3, 2 minus 2 0. So the new available value is 230. So next we will find the need value. Need is equal to need minus request. So the need value is 122 and the request is 102. So 1 minus 1 is 0, 2 minus 0 is 2, and 2 minus 2 is 0. So the new need value is 020. So then after finding the resource type, then we will use safety algorithm. So we will find out whether this condition will be safe state or not. So let's take for process P naught. Need is less than or equal to work. So 743 is less than or equal to 230. No, it is not less than. So P0 must wait. Next we will check for P1. 020 is less than 230. Yes, it is less than. So we will find the new work value. Work is equal to work plus allocation. So 230 plus 302. So the new work value will be 532. So this is the save stage sequence. So if P1. So next we will find for process P2. Um, need minus available, that is 600 less than or equal to need is less than or equal to available. So 600 is less than or equal to 532. So 6 is less than no 6 is less than or 6 is not less than 5. 0 is less than not less than 3, and 0 is not less than 2. So we cannot grant P2 must grant P2, so P2 must wait. So next we will find for process P3. 0, 1, 1 less than or equal to 532. Yes. So new work value will be work plus allocation. So 5 plus 2, 7, 3 plus 1, 4, 2 plus 1, 3. So the new work value will be 7, 4, 3. So this is a save state sequence P1, P3. Next we will find for process P4. Need is 431 less than or equal to available 743. Yes, it is less than. So new work value will be work is equal to work plus allocation. So 743 plus 002. So 7 plus 0 is for 7. 4 plus 0 is 4, and 3 plus 2 is 5. So new work value will be 745. So 745, this is the save state sequence P1, P3, P4. Next we will find for, so P0 is not allocated, so we must find the P0 7. So the available value is 7. So the need value is 743 is less than or equal to available is 745. Yes, it is less than. So new work value will be work plus allocation. Suppose 745 plus allocation is 010. So 7 plus 0 is 7, 4 plus 1 is 5, and 4 plus 0 is 5. So new work value will be 755. So P0 also allocated. Um, Next we will find for P2. Um, uh, need is less than or equal to available 600 is less than or equal to 755. Yes, it is less than. So the new work value will be work plus allocation. So 755 plus 302 allocation 302. So new work value is 10, 5, and 7. So the new work will be 10, 5, 7. So this is the save state sequence. So you see resource request algorithm, we go that this problem will not go for a deadlock. So this is the save state sequence. So this is another example for bankers algorithm. In this they give process allocation maximum and available, and we have to answer the question. That is, we have to find the need matrix, and we have to find out the system is in safe or not. Then if yes, then we have to find out the save state sequence. And then the C part is, if a request from process P1 arise for 1100, can the request be granted immediately? Um, so first of all, we need to find the need matrix. So this is the need value for P0, P1, and P2, P3, and P4 likewise. Then we have to calculate the save state sequence. For this example, this is the save state sequence P0, P3, P4, P1, P2. And if the request from process P1 arises for 1100, can the request be granted immediately? So yes, this request can be granted. If, and the save sequence is P0, P3, P4, P1, and P2. So that's all about Banger's algorithm. So I hope you got all a clear idea about Banger's algorithm. So thank you.